Amazing grace, how sweet the sound that saved a wretch like me. I was once lost, but now I'm proud. Was blind, but now I see. Amazing grace, how sweet the sound that saved a wretch like me. I was once lost, but now I'm proud. Wow. Hello. There seems to be an issue with my VTuber studio, which on my end here it appears very laggy. So before starting the stream, I've been trying to see if I can solve the problem, but it's still laggy. So I guess after the stream, I'm gonna try updating my drivers. Hello, Simon. Hello, Sky. Okay, we're going to continue with the coding pattern for merge intervals. So next one is another medium. Given two lists of intervals, find the intersections of these two lists. Each list consists of disjoint intervals sorted in their start time. Intersection of these two lists. Okay, so in this case, they're only looking for intervals that are overlapping. So 1, 3, 2, 3. The only overlapping part is 2, 3. And then 5, 6. 5, 7. 5, 6 is within 5, 7. And then 7, 9. 5, 7. 7, 7 is only within these two. Hello, Lib. the first thing comes to my mind is that we can do 2 while loops. One loop through this, another one loop through this. But I think we can simplify that because this is gonna be exponential time complexity if we do 2 loops. So online join. Let's move. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The first one 1, 3, 5, 6, 7, 9. 1, 3, 5, 6. Why would you do a 5, 6 and then 7, 9? Shouldn't these two connected? Shouldn't these be connected? And second one is 2, 3. And then 5, 7. So the brute force I think is like you iterate through the first, iterate through this, and then for each iterations iterate through this. But what we know from this problem statement is that these two intervals are already sorted. So we can have a index A, index B. Index A tracks this part, and for each index A, we're gonna look for B, and we are looking for B that's that the starting number is less than the end number. So if you find a starting number is less than end number, we take these two intervals and then we calculate the overlapping part. So just take the overlapping part and then we move on to the next one. After we take the overlapping part, we do an A++. So now A is gonna be looking for this. And then we look at the B part and we take the B. In this case will be still 2. So and then we look at the mean value. Actually I think we should look at the mean value first. If we look at the mean value and 2 is less than 5, then we do a B++. So now B is here. Which language is this? I'm coding in JavaScript. I think language by itself doesn't matter that much. So let's try that. Let's A equal to intervals A less than A equal to 0 and B equal to 0, while A is less than intervals A dot length and B is less than intervals B. We only care about one of them going out of bound because if one of them is out of bound, the second one will not. Actually, one of them overbound, second one can still be. Anyways, first thing we look at is we're gonna take the interval A of A. If interval A of A, actually I want interval B of B, though star is greater than or equal to interval A dot A of A star. So this one we make sure that this is greater than or equal to the interval. If that is true, you have a funny serious question if not disturbing. Who are these 8 people watching coding class at 12 AM? You know the earth is round and 12 AM your time might not be 12 AM their time. Okay, if this star if we have one of these, oh, you don't need to be sorry. Ari, it's midnight for you, so you can be tired, and it's completely understandable. So if we have a star that's greater than, we are taking the so we need to look at star greater than. I think I just need to look at if the star is less than, if the second n is less than the first star, and if second star is less than the first n, But then you also could be overlapping from the other side. If this is the case, then we do a push. Result dot push. New interval. Is it new interval? New interval. And then we pass in math.max interval A. Actually, let's say before we push, let's start n. We're gonna define star as math.max between interval A and interval B. Interval A of A. Interval A at the A index, and then interval B at B index. And then n is gonna be math.min interval A at A dot n. Oh, this should be star. Dot star. And then B dot star. So A dot n at the interval B dot n. Now, and then we can push result dot push new interval star and n. So this is if we find an overlap, and if we don't find an overlap, there are two cases. Either A is greater than B or B is greater than A. So if interval B dot n is greater than interval A dot n, so this case is B is greater than A. So we want to increment A. Otherwise we increment B. So run this. Up is nothing. Depends on the time zone, yeah. Also, in my case, I'm more streaming just to force myself to explain to the viewers. People don't really watch my coding streams. But I want to force myself to, cause like if you ever try to do lead code by yourself, it's very boring. And sometimes like your back of mind is like thinking about, okay, I want to get this over with or something like that. But if I stream, I'm forcing myself to explain. So I guess it helps me. Did you explain to the voices? Do you mean you explain to the void? Hello, Relief. Wait, Lay. Wait, Lay sounds like a a character from an RPG game. Wait, hold on. Wait. There's an anime called like Gates. Gabe something. And there is a girl inside the anime. She uses magic. Her name is Lele. Is that a coincidence? It is a coincidence, okay. Lele from the Coffin and Andy and Lele Q? Oh, I don't know what that is. Okay, output is nothing. Which should not be the case. If interval B dot star, interval A dot star. We can test this by console logging interval A of A and also interval B of B. Run. Console log is empty. Why? Oh, it's less than, okay, dot length. Okay, at least it's working. Except this number should be reversed. So, okay, now, so interval A and B is 1, 3, 2, 3. So, if B dot star is greater than A, which is the case, we do star max of star, which is 2, and then minimum of n, which is 3. So the first one is 2 and 3. That's correct. And then on the next iterations, we look at the n. If the n is greater than, this is not the case, so B++. Now we look at 1, 3, and 5, 7. 1, 3, and 5, 7. This does not trigger because B star is not greater than A star. So we do A++. So now 5, 6, and 5, 7. Because 5 is greater than or equal to this. So star is at maximum star is 5. Minimum n is 6. So result of push 5 and 6. Why is it like this? The output is 5, 3. The output is 5, 3. Also log star n 5 and 3. Oh, because 5 is greater than 1. Okay. 5 is greater than 1. So instead of looking for the star is greater than, I should still be looking at if B dot star is less than A dot n. And then run this. Accept it. The 5, 6, 5, 7, 7. And submit. Run. 2, 5, 10, 6. What is it, 10, 6? So in this case, star is less than the n. So star less than n. And interval b dot star is greater than interval a dot star. Run this. Wrong. Because now we are skipping this one. 5, 6, 7. So 5 is less than 9. 5 is less. Oh, this. Okay. Five less than 9 was true, but 5 is not greater than 7. We need to find if they overlap. If the n is less than or greater than star, run. Only 7, 7. Okay. 5 is no less than 3. Two is less than 3, which is true. 3 is greater than on us. Is that the yes? Oh my god. Okay. Commit. So we basically did one pass. This is the time complexity of n, because we only did one pass. Which n is equal to n is equal to or less than. I mean equal to or less than length of A plus length of B. So on each pass, we look at if the starting number of B is less than the n number of A, and also the n number of B is greater than the start number of A. So we're looking at this number. Is greater than or less than this number, right? Star, hold on, so star is less than or greater than this, and then the n is greater than or less than this. So, and then we can calculate the overlapping bar by taking the maximum value of both star and then the minimum value of both n. And then we push. That's where the overlap is. So, and then in order to determine how to go to the next index, we look at the n value. If this n value is greater than this n value, then for this index we move on 1. But if this n value is greater than this n value, we move on by 1. Sometimes if both of them are equal, this case is fine, because this move by 1, and then we're gonna calculate again, we're gonna compare again. So basically we're comparing this value to this value. But because they are not, this is not greater than the start value of this one. Which means this condition does not satisfy. So we skip this, and then when we skip this, the next time this loop happen again, we're gonna look at the end value, see which one is bigger. Now because the second end value is bigger, we increment this by 1. So now this is now looking at. So now you can using this value looking at this value. And then using this value looking at comparing to this value, and then we take the min max. After min max, because this m value is greater than this m value, so we do a we increment a, and we look from a to here, and then we take the overlap value again. And it's the best. Next. So, like this one did, I did a max or star, max on n. A overlap B is equal to star greater than star n. Otherwise, B overlap A. If either of these overlap, you push the new interval max and min, and then they look at the end. So basically the same, but I turn this part. I think my code is even easier to read than this, because they look at if they overlap from A to B and then B to A, and then they do either of this part. So we can just look at one of them and then push this value. Conflicting appointments. Given an array of interval representing n appointments, final if a person can attend all the appointments. So appointment 1, 4, 2, 5, 7, 9. 1, 4, and 2, 5 overlaps. A person cannot attend both of these appointments. So look at all these values and see if they're overlapping or not. Okay, and this, by looking at this, we know this is not sorted. So first thing we're gonna do, I think we're gonna sort the interval. So intervals is equal to intervals dot sort, and we are comparing A and B. And we are doing A dot star is minus B dot star. So in this case, if I take this value, because this value is not sorted, and then I input this value, and we console logs the interval, we should get a sorted interval. 2, 4, A7, 6, 7, A12, 13. Okay, so now this is sorted. And next we're gonna look for is I think I just need to do a for loop. For loop of let I equal to 0, I less than intervals dot length minus 1, and interval I plus plus. I'm doing minus 1 because I'm gonna take the first index I, and then we're gonna look forward by 1. So if If they are overlap, that means the second interval, the star is less than the first. So if intervals of I plus 1 is less than interval of I, if the star is less than the n, that means the star started before the, that means the next interval started before the first interval is ended. If that's true, then we return false because it's overlapping. I think that's it, then return true. Submit. Accepted, submit. Accepted. Oh my god, this one is easy. This one is so easy. So this one, we look at this interval. So we look at, so first we saw the number. So the beginning time is always from the smallest number to biggest number, and in order for us to find whether they are overlapping, is we take the starting number of the second appointment, and we look at the end number of the first appointment. If this number is less than this number, which means the first appointment is still going on where the second appointment started. And then we move on to the next, and then we look at the second appointment to the last appointment, the end of last appointment. So they're also doing this. Oh, they don't have -1. Why? Oh, they started. Okay, so they are looking backwards. We are looking forwards. So that's only difference. We start at 0, and then they look at backwards. They start at 1, and then they look at backwards. But we start at 0, we look forward. So we're doing left -1, and then they are doing just length. This one is so easy. Okay, problem challenge. Minimum meeting rooms. This is a hard question. Given a list of intervals represent. Wait, hold on. How many people are actually still watching? There are 9 people. Oh my god, there are 9 people watching coding. Is this fun? Given a list of intervals representing the start and end time of n meetings, find the minimum number of rooms required to hold all the meetings. Minimum number of rooms. Okay, so for each overlap, we need 1 room. Since 1, 4, and 2, 5 overlap, we need 2 rooms to hold 2 meetings. 7, 9 can occur in any of the 2 meetings. Visual representation of example 4. So 2, 3 and 2, 4 overlap. But you only need 2 rooms because 3, 5, 4, 5. Because when this is ended, you can start with this. When this is ended, you can start with this. In this case, we are not just looking for overlap. We need to 1, 2, 3, 4, 5, 6. So 2, 3. 2, 4. 3, 5, 4, 5. 8, 5. 4, 5. So we can have a value to store number of rooms. So for each first we can sort them by, we have to sort them by the starting time. Is this pre-sorted? Find the minimum 5. Okay, this is not pre-sorted, so we need to sort we need to sort the room. So if we take the first room, we look at the second room. We take the first room and then we look at the second meeting. If the second meeting overlaps with the first meeting, we gonna do a room plus plus. So if we have a max value, the max value will be 2 now after room plus plus. We can have a time. We can have a timer. We can have a timer and then if they overlap, if these two overlap, then we look at the minimum n value. We look at the minimum n value. In this case, it's 3. And then we look at the next meeting. We look at the starting value, which is also 3. If the n value and start value is equal, if the start value is greater than or less than the n value, then wait, we don't need room plus plus. Oh. So room right now is at 2. If this value is greater than, if this value is greater than or less, then we don't need to make a new room. But if this value is less than this, then we do a room plus plus again. But if room is at 3, and then we look at the third number. If the third number is also less than this, how do we know the first room is finished? That's why I think we need an incrementation for these values. So max and max, we look at number of rooms. And then room will be looking at number of open rooms. So if it's less than, we do a room minus minus. Row is at 2. It is. This will be looking at this value. This won't be looking at the previous min. Yeah, there's a condition here. If row is, if we have more than 2 rooms, and then we need to track whether the first room is finished or not. I can have a hash map. I can have a hash map to store the main value. So main value is 3. Main value is 4. Each time we look at the starting value, we deduct the minimum value. If the starting value is greater than this main value, then we deduct. If it's less than, then we push to this again. And then the maximum will be the size of the hash map. Maybe that's doable. Okay, so we're going to sort the meetings. So meetings is equal to meetings dot sort. We're sorting A and B, where A dot star minus B dot star. And then we're gonna create a hash map. This doesn't have to be hash map. We can just do a array. And then let's I equal to 0, I less than number of meetings or length. Number of meetings or length. What if I start with 1? I start with 1 and then we pre-append the hash with meetings 0 and end time. So hash right now has a end time of the first meeting. Right, so I plus plus. And then for each time we look through this, we look at the We look at the end time. While meetings I, in this case, this is the second meeting. In meetings I, start time is less than. Let's index equal to 0. So if meeting time is less than hash, we should be looking at the. We should be looking at all the meeting that's going on right now. So the meeting time, if the meeting time is less than first one, that doesn't make sense. This only looks at the first index. If meeting time is less than. Actually, first index is fine, because first index means the meeting time is the earliest ending meeting time. Index 0 is at the earliest meeting time. So hash at 0. If the star is less than hash at 0, then we do a hash dot push. Hash dot push. Then we can push a new time. Hash dot push. Meetings. Then we if they overlap, then we create a new room. And we just store the end time of that meeting in the new room. End time of the new rooms. So meetings I dot n. Then we push that. If then we push the new meeting. Else because otherwise they are not overlapping. If they are not overlapping, then we're gonna kick the first meeting out. Hash dot JS remove bus index array. I think it's either shift or pop. Slice 1 or shift. Shift, okay. So otherwise, then we do a hash dot shift. Well, each time we push this, then we just look at the minimum number of rooms is equal to math.max, and we look at minimum number of rooms and the hash dot length, and then we return minimum number of rooms. So submits, accepted, submits, wrong. This is 0. Output is 0. Oh, okay. Because this is minimum 1. Because we are storing the first meeting in there, so this should be 1. We're gonna start this at 1. Run. Run. Minimum is 3. So 1, 3, 3, 5. 4-7 is overlap. Three fire, 4-7. Oh, okay. So instead of shift, we're gonna push hash.0 is equal to, we're gonna override the first end time with the current end time. Meetings I n. Run this again. 3. If this is sorted, the cause one of them could be the. I see what the problem is. So if this sorted, we can have the first meeting to be like super long. Then we have a second one. And we have a third one. And we maybe have a fourth one which is overlap with this. But the current algorithms is only looking at the end time of the first one. So if this is overlap, in this case we have 3 overlaps, so we need 3 rooms. And this is looking at the first one. Looking at the first one. An easy fix to this is if whenever we push a value to the hash, we sort this hash from the end time using the end time. However, the problem immediately the problem is this sorting inside will be end of log n, and we already have a for loop of the length of the inputs, so it'll be n times n of log n, which is not good for time complexity. What type of coding is this? This is the... Do you know Lico? This is basically Lico, but it's just on a different website. You know Python, C++. Oh, those are languages. You're asking me about what type of coding. You're not asking me about what language is this. This is basically like solving coding challenge. I mean, algorithm, is it algorithm? Algorithm coding challenge, where if you apply for big companies, they just it's kind of brain teasing coding questions. Okay, so what I can do here, but I think that's just a band-aid, because each time we push it to a hash, we take a minimum value. If this is less than minimum value, that'd be useful. So minimum value is also meetings 0 and actually, should we care about minimum value? If there's a new meeting, then if the starting time of the current index is less than the hash of the first value, then we push. Okay, there would be easier way to do this. So when we do the push, we can look at the we can look at the value that we want to push. So if the value we want to push ends earlier than the first value that's already exists in there, is earlier than the hash.0. If this ends earlier, then we want the 0 to be okay. JS push to beginning of array. I think it's a slice, combination of slice. Unshift. Okay. So if the second index end time is less than the first index end time, we want the second index end time to be ahead of the first one. So hash dot unshift meetings I end time. Else, otherwise we push. So every time so that means every time when we do this, the beginning of the hash will always be the meeting that ends the first. So if there's no overlap, then we just kick out the first meeting. And the minimum number of runes is whenever there's a rune adjustment. Alright, so if we submit this and then submit this. Lua, you guys are talking about Lua. I heard about Lua, but I never used it before. Because I don't go for games. Although I have seen a lot of source code. I've seen source codes of games in Lua. So that's why I can recognize the. I recognize it, but I don't use Lua. So output is 3, but expected is 2. Submit. Oh, I'm gonna use this accurate. I'm gonna use this as example and then run this. 2, 3, 2, 4, 3, 5, 4, 5. So 2 and 3, 2 and 4. The first meeting end time is here. So if the second meeting start time is less than the end time, this triggers. And if the second end time, if this end time is actually, I should also console log out the hash. Right, so we have rune 1 starts at 3, rune 2 starts at 4. Why is this a 5 here? So the first pass is correct. The second pass is 3 and 5. So 3 looking at 3. Oh, if it's less than or equal to. Well, again. If it's less than or equal to. So this start time is less than or equal to this. And then this end time is less than 3. Which is not. Then we push. Oh, this only happens if there's no overlap. So if the end time is less than the first one's end time, if start time is less than or greater than, this shouldn't be less than or greater than. So this is not... So 3 is not less than 3. Because 3 is not less than 3, then we do a meeting. Then we replace the first meeting with this n. So we replace 3 with 4. Replace 3 with 5. Oh, I see. Replace 3 with 5. But we... After the replace, we need the 4 to be the beginning. Okay, so otherwise let Pam equal to hash at 0. And then hash at 0 is gonna be... Hash at 0 is gonna be math the minimums meetings I and time, and also tenth. So in this case, hash at 1. Wait, this only replaces... We only just replace... We don't want them to... If they're equal... Because this is gonna append a new one. Math down next. Yeah, this is not gonna work. Run. Commit. This is not going to work. Because I'm actually... in the second case of the last one, this will work fine. But in the first case, when the first time this doesn't pass, in this case we're adding a new room. Otherwise, replace this. Now the problem is when we use the n to replace the first value, the second value could be less than the first value. The only easy way to solve this is every time when we modify the hash, we do a sort. Or instead of doing sort, we can keep track of the minimum value. But then if there's if there are more than 2 rooms, then each time when the room increases, we need to increase the minimum value, the number of minimum values. Any help? Let's take a look at above mentioned example 4 and try to follow the merge interval approach. Meeting is this. So these meetings on the starting time, which is what I did. Merging overlapping meetings. So this merge of this merge of this merge of this. Since all given meetings have merged into one big meetings, does this mean they are all overlapping and we need minimum 4 rooms to hold these meetings? You might have already guessed that the answer is no. As we can clearly see, some meetings are mutually exclusive. For example, 2, 3, 3, 5 do not overlap and can happen in one room. So to correctly solve the problem, we need to keep track of the mutual exclusiveness of the overlapping meetings. We can conclude that we need to keep track of end time of all the meetings currently happening. Yeah, that's what I did. So that when we try to schedule a new meetings, we can see the meetings have already ended. We need to put this information in a data structure that can easily give us the smallest ending time. A minimum heat map. Smallest ending time. A main heat map. Minimum room is main heat map size. Since 2 and 4 doesn't end before 2 and 4, 2 and 3 does not end before 2 and 4 start, add 2 and 4 to the minimum heat map. So this is an array of minimum heat map. Three and 5. Remove 2 and 3. Because it's remove 2 and 4. What this one adjusts is that the end time also happen to be less than the next end time. So this will work fine. But if for example if this end time is like 13, they will be removing the first one out of it. So the minimum heat map is it possible that like it may be possible each time what you see in your room, you look at the minimum heat map, you look at the end time, you look at the first end time. Second end time. if the first end time is, if the star is still less than the end time, you look at the second end time, and then you look until you finish looking at the heat map. If there's one that's within the time, that you kick that out. So then there will be another while loop inside. Holy shit, are you kidding me? The solution is... Wait, that's constructor. Yeah, left child and right child swap pop. That's freaking... Wait. Are you sure? This... Okay, this solution here, bro. Look at this solution. The length of this solution. Oh, there's solution here. They saw this. You look at mirror. You look at heat map. New heap. What do you mean new heap? Heap. So they create a new class just for the heat map. New heap A and B. Oh. Heat map pop. He map dot peak. He map dot peak will peak. Return this item 0. He map dot hit Hipify up. Hipify up, you pass in an index. Wait, hold on. Something smells good. Is the phone outside? Wait, hold on. Be right back. I shouldn't be smelling things because all my windows are closed. I guess my neighbor is cooking, but the problem is I shouldn't be smelling the thing. Hibify up is, you look at this. He map parent current. Compare each item and then parent item. And you swap these items. Holy shit. So everything here Everything here is part of the solution. This is way too fucking long. Okay, up to number so they have 149 lines. The solution is 149 lines. Okay, I can make it smaller. So instead of doing this, we put a hash in there, and then every time when we okay, I see why it takes so long. So right now we are assuming the start of the heat map is the smallest value. So instead of this smallest value, every time when we look at this, what if I forget all this? What if I forget all this? Every time when the heat map changes, I still need to just look at the end time. Every time when the heat map changes, we do a hash equal to hash dot sort. Look at AB value. AB value is equal to A minus B. Every time when this modifies, every time when something enters the heat map, we sort the heat map from this. Here it's less than. If it's less than, then it's overlapping. If it's less than, it's overlapping. is no less than, we replace. Functional mode. I'll take this value and then use as an example and run this. Hash as 34455. Three and 4455. So this and this, 3 and 4, makes sense. And then when the 5 enters, 3 gets replaced by 5. So we have a 5 here. Oh, because this 3 is no less than 3. So we have a 5 that enters the value, so it will become 4, 5. It becomes 4, 5. So this becomes 4, 5. And then where the next one 4, it also ends at 4. Wait, the start time of this is 4. Hash 0 is at 4. It's no less than... It's no less than the first end time. Oh, because after this change, this order. So we have every time when this modifies, we do a sort. Now it's correct. Submit. Correct. There. Okay. So I managed to do this. I managed to do this in like 10 lines. 10 lines. Versus this question. Versus this is 149 lines. So we have a heat map. The only issue here is like, if every meeting, start time and end time is already pre-sorted, so that would be easy. But the end time is not the same way as the start time that's sorted. So we can have a room that has a very, very long meetings, and everything else is just smaller meetings. So whenever we create a new room for a meeting, we keep track of the smallest meeting time. Yeah, this is kind of time complexity kind of high. If we keep track of that, we use the main value. If we just use the main value, in that case, we need to main value. We need to push that main value to the beginning of the hash map. Yeah, I think that's kind of too complicated. Okay. At least we solved a hard question. How efficient that is, we leave that to the next. I'm not gonna write like that many lines of code just to solve one algorithm questions. I don't think, cause in a normal interview standings, I think they want you to solve 2 questions within 1 hour, and that particular hard question, will already take you more than an hour. So usually in those cases, they just look at how you approach the question, not the final answer. So I think that what I did kind of satisfied the condition for the interviews. So that's it. I'm gonna end the stream here, and next time we're gonna continue to the new pattern, which is called cyclic sort. Yeah, I see you guys next time. Bye bye.